Okay, so far I've talked about the compiler as just this thing that's out there that does something for you, but I haven't really said anything about what it is or what it does for you. So this episode is really all about answering those questions surrounding the compiler and the linker and how do we actually do the workflow associated with C++ programming. Okay, so before diving into all that, just a heads up, this is going to be a really tricky and detailed episode. So before you try to absorb all of this and your head explodes, just keep in mind that the details at this point aren't important, but understanding the overall process is. And the only way I can think of to relay the overall process is to sort of go off into the weeds a little bit. Okay, so digital computers use digital information, and that means numbers. And the place where computation happens is in a processor, usually either the central processing unit or sometimes a graphics processing unit. And processors use super low level instructions like reading and writing to special memory called registers, adding or multiplying the contents of two registers, incrementing the value in a register, and so on. Really, this is mind-bogglingly low-level stuff. Some people love this, and other people just you'll learn it and then kind of forget that it's there. So, for example, the compiler takes this little C++ function and it turns it into low-level instructions that look like this. And I'm lying to you a little bit. This is actually assembly code, which is basically machine code that's written in a way that humans, or at least some humans, can understand. And frankly, I'm not one of them. I'm not a low-level guy. Okay, so since you've had a bunch of Python already, let's talk about this in Python terms. So a Python program that looks like this is really just a sequence of letters and punctuation and that lets the interpreter do something with it. The interpreter converts Python code like this into a sequence of numbers that the computer can use more readily. It turns out that if you can capture a compiled version of this program, it looks like this. Now, you don't need to know exactly what's going on here. In fact, I don't really know the details of this either, and I've actually written interpreters and compilers. The point here is that the Python interpreter converts your lovely human-readable Python program into a sequence of numbers like that. And this stretch of numbers is what the interpreter actually runs. And by the way, this isn't complete gibberish, meaning you can make sense of it if you know what to look for. So here's what the hello world string is encoded right there. So capital H is 48, lowercase e is 65, and so on. All the other numbers deal with loading the program, setting up contexts, and calling the print function. But unless you're writing a new Python interpreter or something really weird, you don't really need to know these details. Okay, so C++ and really any language involves some processing of converting your lovely human readable source code into a sequence of numbers that the computer can actually use. The numbers I just showed for Python are called bytecodes, which is an intermediate form of your program that's used to create the low-level instructions that the computer actually uses. In C++, your source files undergo several transformations before your program can actually execute. You've seen this diagram before. And this shows your source file compiled into an intermediate form, which we call an object file. And then there's another step that takes an object file, or object files plural, to make a final standalone executable that doesn't need any interpreter to run. An executable is simply a file that contains instructions that the computer can run directly. To get one of those, we need to take our object files, or files plural, and link them into a single executable file. This stage is called linking. Say you have a few different source files, add numbers, multiply numbers, and main. Each file has one function in it. If we want to make an executable out of these files, the first thing we need to do is link the objects. So let's create the objects by compiling the source files one at a time. So this is how I compile a file using the GNU C++ compiler. And no, you don't need to know how to do this just yet. The thing I'm showing here is just pretty tedious. So the output of the compile command is an object file. This gives us addnumbers.o. And you'll have to compile each individual source file. It's very tedious. very, very tedious. Okay, so now we have these three object files that the compiler wrote to our disk. We can now have the linker combine these into a single file that we can execute. This is the command. This is another very tedious thing because we're listing every object file that we need there. The output of the linking step is our executable, which I've named foobar, which is the traditional name for something when you don't have anything better to call it, and I'm actually serious about that. Okay, so now we've got foobar written to disk. Now we can execute it from the command line, but it doesn't output anything. There's no print statement or anything. All it does is performs a couple of silly computations and returns the result from the main function. The main function actually, it adds 4 plus 9 to get 13, and then multiplies 10 to get 130. So when we run the program and show the result, it prints 130 to the screen. That echo question mark part is just that's just a command line thing to print out the results of the most recent command, which was our foobar program. Okay, so that's compiling and linking and running your program. And I do want to apologize for how much there is to take in here all at once. But we're getting closer to having all the little bits and pieces of about how C++ and the related tools work.